Hi again. We're going to finish up chapter 4 by doing multiplying and dividing polynomials together. And there's two basic ways that we're going to be talking about multiplying, and then we'll talk about two different ways to do division as well. 4.4 is multiplying polynomials. So the first way that we're going to talk about in multiplying is that we will distribute. And we've talked about distributing before, but not really with x's or variables that have a power on them. And so we're going to add a few powers here when we do this. When you distribute with a variable to a power like we have here an x cubed that will get distributed on each one, then what was going to happen is you add your exponents together. The numbers get multiplied in front, so the 6 times the 2 will still make 12. But the powers get added, so the x cubed and the x squared will give you x to the 5th. Very much like what we were doing in the last section with the integers. If you have like bases, you add your powers. Same thing. Then we would distribute the second one, the 6x cubed onto the minus 5x. 6 times 5 makes 30. And then we'll have x to the 4th because there's 3, and there's an understood 1 on the x. And then on the last one, on the 9, 6 times 9 is 54. And there is no x's to add together, so that would be it. That would be your answer. So you're multiplying the numbers and you're adding the powers. Now, if you just that is just a one term onto a three term. If you did a two term polynomial onto a three term polynomial like we have in the second example, it's a little bit more complicated, but not too bad. I'm going to try to do a little bit more color coding here to kind of show you what's going on. But what we'll do is we'll take the first term times the first term all the way across. So the 6 times 9 makes 54. And we're adding the powers. So 1 and 2 make 3. Then we'll do the 6x times the 2. 2x. 6 times 2 makes 12. And we'll have x squared. And then we'll do the 6x times the 9. 6 times 9 again is 54. No x's to add together at this point. And then we do the exact same process with the ones on the bottom. Not the bottom, the second ones, sorry. The 9 will get multiplied by the 9x squared, which will give you 81 x squared. And notice, I like to line them up so the x squared is matched, so we can just add them straight together in just a moment. I'll do the 9 times the 2, which will give me 18x. And then I'll do 9 times the 9 on the end, which is 81. If I add them all together, I'll have 54x cubed, 93x squared, adding straight up and down, 5, 6, 70, 2x, and 81. And that would be my answer. And so when you're doing a 2 term times a 3 term, just multiply the first term all the way across and multiply the second term all the way across, and you're going to add your like terms together. One of the other methods that pops up a lot is foiling. And so if you know what FOIL is, that's great. If not, I'll give you kind of a short rundown. FOIL is the first letter of an acronym. So the F is for first. The O is for outside. Oops. The O was already there. I shouldn't put another O. For the outside. The I is for the inside. And then the L is for the last terms. So that's what FOIL means. And so when we're looking at foiling, you're looking at 2 terms multiplied by 2 terms. So like in the first one, 3b minus 3 is then multiplied by 4b plus 5. And so doing this foiling, I would do the first terms, 3 times the 4 gives me 12, and b times b gives me b squared. Then I would do the outside, which would be the 3b and the 5. That would be 15. 5 times 3 is 15. B. Then I would do the inside. The negative 3 times the 4 is negative 12. B. And then I would do the last ones. The negative 3 times the 5 makes negative 15. And just like on the one I did before on the previous page, I like to line them up because the 2 in the middle almost always go together. And so we'll have a 12b squared, a plus 3b, and a minus 15. And foiling is one of the topics that most people remember from a previous course, and that's one of the easier topics for a lot of people. So if it is easier for you and you want to kind of scoot on past this part, that's okay. One thing I do want to point out is that the variable is important. A lot of people get used to putting an x in the blank. And so if you put an x instead of a b, like on this first example, it will not give you credit for it. You have to make sure you match the letters. If I do the second one, I would do the r times the r. That would give me r squared. You're just adding your powers together. Then I would do the outside. Would be a minus 8r, multiplying the 8 and the r. Do the inside gives me a 10r. And doing the last one gives me minus 80. If I add them together, I'll get r squared plus 2r minus 80. And I'll do one more like that before we'll do some more, but the next ones are a little bit different. If I do the first one times the first one, 6 times 5 is 30. And now we're doing the letter c, so this is c squared. 5 times 5 is 25, c. The inside, 6 times 3 is 18. It's a minus 18 because of the minus sign in front. And the last one's 3 times 5 makes minus 15. Add them straight together, so we get 30c squared. 25 minus 18 is 7c, and a minus 15. And that would be your answer. Now, these are also foiling problems, but they also have different names as well. The first two, you'll notice it's x minus 4 squared or 2x plus 2y squared. The squared, just like when we did exponents in the other sections, if I had 7 squared, that means that I have 7 times 7. I have 2 7s multiplied. So x minus 4 squared means I have 2 x minus 4s multiplied. And we can FOIL that. This is also, if you happen to look on the view an example or help me solve this online, this is also called a perfect square trinomial. There is a formula for that, but I have found in the past that most people would prefer just to FOIL it together. So that's what I'm going to do. I'm going to FOIL it. The x times the x, the first times the first, gives me x squared. The outside, x times minus 4 is minus 4x. The inside, negative 4x, and negative 4 times x is negative 4x. And the last one's 4 times 4 gives me 16. You'll notice that the two in the middle, the inside and the outside, are exactly the same thing. That always happens on a perfect square trinomial. And you'll end up with x squared minus 8x plus 16. And that would be your answer. And you do the same thing if it's got 2x and 2y on there. This is 2x plus 2y just written down twice. But the process is the same. I do the first one times the first one. 2 times 2 gives me 4x squared. The outside, 2x times 2y. The 2 times 2 makes 4, but the x and the y are not the same base, so they do not combine together. You just multiply the x times the y. And likewise, the same thing in the middle. The 2 times the 2 will give me a 4, but the x and the y are not like terms, so they do not combine together. And the last ones will give me a 4y squared. Again, notice the two terms in the middle are actually the same term. That makes a perfect square trinomial. And I'm left with 4x squared plus 8xy plus 4y squared. The last two are not actually perfect square trinomials. They're actually what we call difference of squares. And we'll talk more about that in the next chapter. The difference is they're not exactly the same, but they're really close. The only difference between the first and the second set of parentheses is the plus or the minus sign. What that typically means is that our middle terms won't combine together, but they'll actually cancel each other off. So I'll do the same process again. The first one times the first one gives me x squared. The outside, x times negative 5 is negative 5x. The inside, 5 times x is 5x. And the last one, 5 times minus 5 is minus 25. So notice here, the plus 5x and the minus 5x completely cancel. These are now gone. And so we're left with just x squared minus 25. And that's my answer. And the last one will do the same thing. People also get in the mindset of these last two problems that you just have to multiply the first ones and the last ones and you get the answer. That works only on this problem. That doesn't work on any of the rest of the FOILings. So if I do the first one times the first one here, 3 times 3 is 9 x squared. The outside, 3 times negative 4 would be negative 12 xy squared, because again the x and the y squared are not like terms, so they don't combine together correctly. The 4 times the 3 in the middle will also give you 12. Oops, the one didn't show up. 12xy squared. And the last ones, 4 times negative 4 is negative 16 y to the fourth. So when you add them together, again, the 2 in the middle cancel to give you 9x squared minus 16y to the fourth. You may also notice that the perfect square trinomials, or in this case, the difference of squares, they all have numbers that are perfect squares in them. Like the first one has 16 in it, which is 4 times 4. The second one has 4s in it, which is 2 times 2. The third one has 25, which is 5 squared, and the last one has 3 squared and 4 squared. Okay, when we're dividing polynomials, you're looking at, again, one of two ideas. You're either going to divide by a single term, or you might divide by multiple terms. And so if you're dividing by one term in the denominator, then what we would do is we rewrite our problem in terms of fractions so that we can simplify them using our exponent rules. If there is more than one term, though, that's what we'll be doing most of, we will rewrite it so that we'll do long division to divide them off. With this first one, I would just rewrite this as 24m cubed over 4m squared, 16m squared over 4m squared, and 16m over 4m squared. So I just write the 4m squared underneath each term. The numbers are treated just like any other numbers when you're dividing. 4 goes into 24 6 times. 4 goes into 16 4 times. And 4 goes into 16 4 times. So we divide that out. The powers on the m's are treated with our exponent rules. If it's bigger on the top, you subtract them and put it on the top. If it's bigger on the bottom, you subtract them and put it on the bottom. One thing to notice here, though, is the m squared on the middle one, m squared divided by m squared. This is the exact same thing. So these two actually just cancel each other off. So what I'm left with is 6m to the 3 minus 2, subtracting the powers. The middle one's just 4 because everything else canceled. And the last one is 4 over m to the 2 minus 1. It goes on the bottom because the 2 is bigger. And that gives me 6m plus 4 over m. And that's my answer. And anytime you're dividing by a single term, this is the best way to do it. Now, if you're not dividing by a single term, you're probably dividing by, in this case, 2 terms. You can divide by as many terms as you want, but we're going to keep it as simple as possible and only divide by 2 terms. So there's 2 terms, 7x plus 4. That is being divided into 7x cubed minus 52x squared minus 81x minus 28. And so there's kind of a 4-step or so process in doing this. And so I'm going to kind of on the right-hand side over here write down those 4 steps. So the first step is to divide the first term by the first term on the outside. And what I mean by that, there's a 7x cubed inside. That's the first term listed underneath the division sign here. And so I would take that 7x cubed and I would divide it by the 7x in front. And just like what we just did with our dividing the one term to the one term, the 7's cancel. And so all you're left with is x cubed over x. Subtract your powers, 3 minus 1 gives you x squared. So x squared goes right here. I lined them up over the x squared underneath it, but that's not a requirement. Second step. Multiply it back. So the x squared times the 7x sitting way out in front gives me 7x cubed. And the x squared times the 4 gives me 4x squared. Third step. We're going to swap the signs and add them together. So I'm going to make these both minus signs. And the reason you do that is so that the first ones will always cancel. That's the goal here. If I add them together, I'll end up with a negative 56x squared. Then what we're going to do is bring down the next term. And repeat. So I bring down this next term, this negative 81x, and I do the exact same process again. Now my first term to be divided by is now the negative 56x squared. So I'll take the negative 56x squared and divide it by the same 7x. The 7x is not going to change, whatever that first term is out front. 56 divided by 7 will give me 8. It'll be negative 8 since it's negative 56. And I'll have an x left over. I multiply that back. The negative 8x times the 7 is negative 56x squared. Negative 8 times 4 is negative 32x. Third step, we're going to add them together after we swap the signs. So we're going to make them both positive so that the first term's canceled. And negative 81 plus 32 gives me negative 49x. Then we will bring down the next term and repeat the process again. I will divide the negative 49x by the 7x out front, which gives me negative 7. The x's cancel. Negative 7 goes on top. Multiply it back. Negative 7 times 7 is negative 49x. Negative 7 times 4 is negative 28. Swap the signs and add them together. In this case, not only does the negative 49x cancel, but also the 28's cancel. And that's okay, because at this step we're done anyway, and we're left with 0 left over. That 0, just like it was when you did division in, say, the 4th grade, that 0 is the remainder. And so there is a 0 remainder here. And your answer is whatever's sitting on top. This up here at the top, the x squared minus 8x minus 7 would be your answer. So I'm going to show you a couple more of these just to kind of give you a few more examples to look at. So this one's written kind of in a different format, so I'm going to rewrite this one to look like the previous one. So instead of this long polynomial divided by 6b plus 3, I'm going to write the 6b plus 3 out in front using the same sort of notation we did a while ago. And I'll have the 36b cubed plus 6b squared plus 42, I left the 2 off, 42b plus 31. And we're going to go through that same process again of those 4 steps. It is important to notice that they are in descending order. You do have to have all your terms in descending order. So we're going to do the first term underneath, the 36b cubed, divide that by the 6b in the front. 36 divided by 6 is 6, and b cubed minus the 1b on the bottom gives me b squared. So I'll have a 6b squared. Multiply that back. 6 times 6 gives me 36, and then b cubed, if you add your powers together. 6 times 3 gives me 18, b squared. I swap the signs so that the first ones cancel. Add them together, which will give me a negative 12b squared. And I bring down the next term. And I do the same process again. The bad thing is, if you ever mess this process up anywhere along the way, there is no coming back from it. It's a lot easier just to throw that piece of paper away and start all the way over. And so we'll do the negative 12b squared divided by the 6b. Negative 12 divided by 6 is negative 2, and I'll have 1b left over. Multiply it back, gives me a negative 12b squared and a minus 6b. 3 times negative 2 is negative 6. Swap the signs so that the first ones cancel. And 42 and 6 gives me 48. Bring down the next term. And do it again. I'll do the 48b divided by the 6b. The b's cancel here, and 48 divided by 6 is just 8. Multiply it back. 8 times 6 is 48. And 8 times 3 is 24. Add them together after we swap the signs. Here, unlike the last one, they don't both cancel. And so the 48b's cancel, but 31 minus 24 does not cancel. That leaves you a 7 left over. That 7 is your remainder. And since it is a remainder, you have to take it and stick it back up here as part of your answer by doing that number divided by whatever you divided by. In our case, 6b plus 3. And this whole thing, oops, kind of went through the 6 there. This whole thing is then your answer. All of this, including the remainder part. Now, I've had students in the past get it wrong because they didn't go all the way through the problem. Once they figured out that 48 divided by 6 was 8 and put the plus 8 up there, they would just quit and say that was the answer. But sometimes if you do have a remainder, that will not be the entire answer, so be careful. Okay, we'll do one more. This one's a little bit easier one. X plus 7 gets divided into x squared plus 15x plus 56. So if I take the x plus 7, and I'm going to divide it into the x squared plus 15x plus 56. Again, same process. I start the first one underneath, divided by the first one out front. In this case, no numbers, they're just x's. So when you subtract those powers, you just end up with an x left over. X times x, multiplying it back will give me x squared, and x times 7 gives me 7x. Swap the signs and add them together so that the x squareds cancel. And that'll leave me with 8x left over. Then I bring down the next term, which is the 56. And repeat that process. I'll divide the 8x by the x in front, which is 8. Multiply it back. 8 times x is 8x. 8 times 7 is 56. Swap the signs, and again here, both of them cancel, which gives me a remainder of 0, which means the x plus 8 was my answer. Now we're going to take this idea a step further in the next chapter and say, well, if I notice x squared plus 8x plus 56, there are two numbers that multiply to 56 that add to 15. That would be 8 times 7. So you notice the 7 is what I divided by, so the 8 would have been the other one left over. And we're going to continue that idea in the next chapter.